What is thermal conductivity? Heat transfer explained. Imagine holding a metal spoon in a hot cup of coffee. The spoon quickly warms up, but a plastic spoon stays cool. Why does this happen? It all comes down to thermal conductivity. Thermal conductivity is a property that tells us how well a material can transfer heat. It measures how easily heat moves through a substance without the material itself moving. This property is represented by the letter K and is measured in watts per meter Kelvin. A high value means heat passes through quickly, while a low value means the material resists heat flow. Heat transfer happens in three main ways: conduction, convection, and radiation. Thermal conductivity relates specifically to conduction, which is the transfer of heat through direct contact. In conduction, heat moves from a hot area to a cooler one by atoms and electrons vibrating and bumping into each other inside the material. Unlike convection, which involves moving fluids like air or water, conduction doesn't require the material to flow or move. Fourier's law explains how conduction works. It states that the rate of heat transfer depends on the temperature difference and the material's thermal conductivity. The bigger the temperature difference, the faster heat moves. The law uses a simple equation. The heat flux equals the negative of the thermal conductivity times the temperature gradient. This means that if a material has a high thermal conductivity, it can transfer heat faster for the same temperature difference. Different materials have different thermal conductivities. Metals like copper and aluminum have high values, making them excellent conductors. That is why they are used in cooking pots and heat sinks to spread heat quickly. Materials like wood, plastic, and air have low thermal conductivity, so they are good insulators. They slow down heat transfer, helping to keep things warm or cold. Thermal conductivity also changes with temperature and physical state. Metals tend to have slightly lower thermal conductivity as they get hotter. Gases, on the other hand, can have their thermal conductivity increase with temperature. Knowing how thermal conductivity works helps in designing better insulation for buildings, managing heat in electronic devices, and improving energy efficiency. In simple terms, thermal conductivity explains how heat moves through different materials. It helps us understand why some materials heat up fast and others resist heat flow. This knowledge is key in many everyday applications, from cooking to keeping buildings warm or cool.